Objective 4. Use the empirical rule to describe data that are bell-shaped. If data have a distribution that is bell-shaped, the empirical rule can be used to determine the percentage of data that will lie within k standard deviations of the mean. The empirical rule states the following. If a distribution is roughly bell-shaped, then approximately 68% of the data will lie within 1 standard deviation of the mean. That is, approximately 68% of the data will lie between mu minus 1 times sigma and mu plus 1 times sigma. Approximately 95% of the data will lie within 2 standard deviations of the mean. That is, approximately 95% of the data will lie between mu minus 2 times sigma and mu plus 2 times sigma. And then approximately 99.7% of the data will lie within 3 standard deviations of the mean. And that is, approximately 99.7% of the data will lie between mu minus 3 times sigma and mu plus 3 times sigma. Now note that the empirical rule can also be used based on sample data with the sample mean in place of the population mean and the sample standard deviation S in place of the population standard deviation of sigma. Now the figure below illustrates the empirical rule. In the figure, the symbol here means approximately. Okay, now the mean here is denoted by mu, which is in the middle, while the standard deviation is denoted by sigma. Mu is marked at the center, mu minus sigma is marked to the left, and mu plus sigma is marked to the right. The difference between mu minus sigma and mu, as well as mu and mu plus sigma, is 34% each. Together, the distance between those two has been marked as 68% within 1 standard deviation. So we can see here to the left of this value is 34%. This is also 34%. When you add them together, it gives 68%, which is with 1 standard, it's within 1 standard deviation of the mean. Okay, now remember, the mean is denoted by mu, while the standard deviation is denoted by sigma. Okay? Now, we also know that about 35% is within 2 standard deviations. So we have this 34%, this 34%, okay, which is 1 standard deviation from the mean. And then we have 2 standard deviations from the mean, which is an extra 13.5%, 13.5%. And so when we add these together, we're going to get a total of 95% within 2 standard deviations. Okay, now if we wanted to, if we added this 34% plus 13.5%, well, that's going to give us, excuse me, let me go ahead and rewrite that here. That's going to give us 47.5%. Okay, and likewise on this side, this would also give us 47.5%. So that means that's 2 standard deviations away from the mean. If you add 47.5 plus 47.5, it's going to give you 95%. Okay, now we then can see the 99.7% of the data. So if we take a look at the 99.75% of the data, okay, that means that it's 3 standard deviations from the mean. So that means we're going 3 standard deviations. So that means we're adding 34 plus 13.5 plus 2.35%. Okay, same thing on the other side, 3 standard deviations away from the mean. 34%, 13.5%, 2.35%. When we add those together, we're going to get 99.7% of the data, which are within 3 standard deviations of the mean. So, just like we did before, okay, if we take a look at this 34 plus 13.5 plus 2.35, okay, what does that give us? Well, that gives us 49.85%. Okay, same thing over here. okay, if we add those together, we're going to get 49.85%. So if we take 49.85 and add 49.85, we get, let me rewrite that again, 49.85 plus 49.85, that gives us 99.7. So that's where it's telling us it's within 3 standard deviations away from the mean. Now, if we take 100, okay, and then we subtract 100% is the full 100%. If we subtract 99.7, okay, that's how much is left over, 0.3. So 0.3 is what's left. Now, if we take that 0.3 and divide it by 2, it's going to give us 0.15. So that means 0.15% on the right side and 0.15% on the left side is outside of the 3 standard deviations from the mean. So we're going to use this figure in our next example. So for example, we're going to use the empirical rule. So the table 9 represents the IQs of random sample of 100 students at a university. Okay. Now for part A, we're going to determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. To make the analysis easier, you draw a bell-shaped curve like the one below here with a mean of 100. So we can see here that the sample mean is 100, okay? And the sample standard deviation is 16.1. So let's just take a look at the bottom here. So if we take the mean, which is 100, and then we add 1 standard deviation, then what do we get? Then we get the following. We get 16.1, 116.1. That's 1 standard deviation above the mean. Likewise, if we take 100 of the mean and then subtract the standard deviation, then what do we get? Well, then we get 83.9, which represents the values that is 1 standard deviation below the mean. So that means everything from here is going to represent everything that's 1 standard deviation below the mean. Okay, next, okay, we're going to see this 100. That 100 is now going to be added to 2 plus standard deviations from the mean. So let's go ahead and do that. So we have 2 times the standard deviation from the mean, which gives us 132.2. So we can see here that when we multiply 2 times 16.1 and add 100, it gives us 132.2. Likewise, we're going to take our 100 and we're going to subtract 2 times 16.1, which gives us 67.8. So that represents numbers that are 2 standard deviations from the mean. Okay? And then lastly, we're going to take our mean, right, which is 100 here, and then 100 here, and then we're going to add 3 times the standard deviation and subtract 3 times the standard deviation. Okay, and then what is it going to give us? It's going to give us the following. It's going to give us 51.7 here and 148.3 here. So that represents 3 standard deviations away from the mean. Okay, so our question says determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Okay, so we know that if we take a look at this, we know that 2.35%, 13.5%, 34%, 34%, 13.5%, 2.35%, okay, represents all the percents that are within 3 standard deviations from the mean. So that means if we add those all together, if we take 2.35% plus 13.5% plus 34% plus 34% plus 13.5% plus 2.35%, we know it's going to give us 99.7%. So we don't even have to add that up because we already know it's a general rule. 3 standard deviations away from the mean is going to give you 99.7%. And that means that it's either greater than or equal to 51.7 or less than the score of 148.3. Okay, now let's determine the percentage of students who have IQ scores between 67.8 and 132.2 according to the empirical rule. Well, let's highlight that. Okay, so we're going to highlight where 67.8 is. So here's 67.8. It's at that. And then the next value is 132.2, which is here. So here is 132.2. So what we're going to do is we're going to look at that result. Okay, so now we're going to add 13.5% with 34%, 34%, and 13.5%. So what does that give us? Well, when we add those together, when we add 13.5% plus 34% plus 34% plus 13.5%, well, that gives us approximately 95%. And again, because 67.8 is exactly 2 standard deviations below the mean, and 132.2 is exactly 2 standard deviations above the mean, then the empirical rule tells us that approximately 95% of all IQ scores lie between those two scores. Next, we want to determine the actual percentage of students who have IQ scores between 67.8 and 132.2%. Now, of the 100 IQ scores listed in that table, a total of 96 or 96% are between 67.8 and 132.2. This is very close to the empirical rule's approximation. Part D. It says, according to the empirical rule, what percentage of students have IQ scores between 116.1 and 148.3? So let's go ahead and take a look at that. So we're looking at 116.1 and then 148.3. Well, this represents all the information that's in between those two values. So the percentage is 13.5% and 2.35%. So based on the figure, approximately 13.5% plus 2.35% is going to equal 15.85% of students that have IQ scores between 116.1 and 148.3.